Right, okay. So hello everybody and good evening. So this is our session on activity-based planning. So I shall just click through. Our housekeeping rules are the same as usual, so I won't spend too long on those. So the purpose of this session is to really understand the classical method of planning a project. We're going to follow a review of what's involved in activity-based planning. We're going to review the place of activity-based planning within the project life cycle, and we're going to practice an exercise in activity-based planning. And then there is an assignment at the end for you to practice what you've learned. And the payoff is that you'll gain the basic knowledge and ability to plan a project based on activity-based planning. So that's what we're doing. So activity-based planning is a planning process that tries to identify all the tasks that need to be completed, to identify the resources that need to complete each task, and schedules the task to start when it needs to. And it really is the classical approach to project management. The Egyptians who built the pyramids used activity-based planning, as did the Romans who built the roads and viaduct across Europe in late antiquity. The engineers who built the great infrastructure projects in the 18th and 19th centuries, the canals, the railways and the bridges, they also used activity-based planning. But they may not have used some of the refinements that were developed as a result of the scientific methods that we use to study project management in the late 20th century. So if we have to identify all the tasks, we need to think about how big that's going to be. So for small, simple projects, the tasks list is going to be quite short. The list of tasks can be very long. And as the size and complexity of a project increases, it becomes more and more likely that critical tasks are not identified during planning. So there's a risk there. Our list of tasks is usually organised so that the activities are arranged in the order that they need to be completed. And this list can be divided up into the stages of the project. So we're going to look at a method to try to avoid missing these critical tasks, because if we miss anything, then the project may fail. So we need to try to make sure that we don't miss anything when we're trying to identify the tasks that need to be completed. So what we're going to look at is the idea of decomposition. And I've got this word defined here. So decomposition is the process of breaking things down into smaller and smaller parts. And it's a proven technique to ensure that all the tasks are discovered during planning a project. Because the major tasks within a project are usually quite easy to discover. So for example, if our project is to build a new bridge over a major river, there may be just 3 distinct tasks that we can identify. We need to design the bridge, we need to build the bridge, and we need to hold an open ceremony. Now you might, depending on the project, decide that there's a step that comes before that, which is to survey the possible sites for the bridge. But we can see that we've identified the major tasks for building a new bridge over a major river. And having discovered these major tasks, we can decompose these tasks into slightly smaller tasks. And that's what we mean by decomposing. We're going to repeat this process of breaking a major task down into slightly smaller tasks. And we're going to keep doing that until the exercise starts to not deliver any further value or further insight as to the tasks that need to be done. Okay. Now, if we have an expert that's working on the project and they're an expert in their field, we may not need to decompose their tasks for them. We may be able to give them a major task, such as designing a bridge for a particular location, And if they're an expert in designing bridges, we may not need to break the task down for them. They may have their own breakdown in their head in the same way that an Egyptian master mason building a pyramid would instinctively know the tasks for his work. So experts in some cases to know how tasks are broken down, but in large projects it's often the case that we need a subject matter expert, somebody that knows about the task, in order to tell us how it can be broken down, because there may be different options as to how to break it down, and different options may be more suitable for our project. So this is what we are trying to understand is, what are the tasks? Who can tell us what those tasks are? And what we are creating when we break the tasks down is something called a work breakdown structure. And that relates to the title of this slide and the next few slides, because we're talking about how we break down the work into a structure that everyone that's working on the project can see and understand. So everybody knows their job and they know how all the tasks fit together. So we'll move on and take a look at the next slide about the work breakdown structure. So as we start to decompose our major tasks, we might take the design bridge task and decide that that breaks down into two subtasks: surveying the site and then designing to suit the site conditions, because the bridge has to have the right sort of foundations for the site that it's going to sit on. And you might decide that building the bridge might break down into these tasks that we have. So recruiting the workers, ordering all the materials, building the foundations, building the bridge structure, and then building the roadway on top of that bridge structure. So we're taking the build bridge task and we're breaking it down into these smaller tasks so that we can see more detail about the steps that need to be done and the order in which they need to be done, because clearly you're going to need some materials and some workers before you can start building. And there is a natural order to the order in which you would build a bridge. You would start with the foundations, you would build the structure, and then you would build either a railway or a road or a footpath or whatever the bridge is for. And then you might take the hold the opening ceremony task that we identified and break that down into identifying a dignitary that will open the bridge, scheduling an open date and writing press releases to invite people to the opening, and actually holding the ceremony. So you can see that we're breaking each of the major tasks down into separate tasks that perhaps have a particular start point, a particular duration, and a particular aim in mind in terms of delivering the project. And we can show our work breakdown structure as in many different forms. So in the top left of this slide, I've shown it as an indented list where we've got designing the bridge at one level, and then we indent to see the survey site and designing the bridge to suit site conditions. And then I've got a third level of detail where I've decomposed designing the bridge to suit the site conditions into designing the roadway in order to determine the load on the structure, designing the bridge structure in order to determine the load on the foundations, and then designing the foundations. So you can see that in designing the bridge, we're working our way from the top down, because we need to understand how the load is passed from the roadway through the bridge structure to the foundations. And that's information that you only know that that's the right way to design a bridge if you've built a bridge before. And this is one of the reasons why for business projects, you often need a subject matter expert who can tell you what the right tasks are and what the right order for tasks are. But how we present the work breakdown structure is very much up to us. So in the bottom left corner of the slide, we've got exactly the same project, exactly the same tasks, but we've shown it as a tree structure where we start with our new bridge at the top. And then we've got over on the left-hand side, we design the bridge. That's broken down into a site survey and designing the bridge to meet the site conditions. And then designing the bridge is broken down into designing the roadway, designing the bridge structure, and designing the foundations. And that process continues through the diagram. So where we're building the bridge, we need to recruit our workers, we need to order materials, we need to build the foundations, we need to build the bridge structure, we need to build the roadway. Holding the opening ceremony, that is also broken down. Okay. So holding the opening ceremony is also broken down into these steps of identifying a dignitary that can open the bridge, scheduling an opening date, and holding the ceremony. So the structure in the top left of the slide and the structure in the bottom left of the slide are showing exactly the same thing. And we can also show the same information within a project management tool. And that's what I've got in the bottom right-hand corner of this slide, where we've got a software tool and we've got the same tasks that need to be done. But because this is a software tool, we can put other information in, such as the date when these tasks are going to start and when they're going to finish. And we can do other things with the tool, as we'll see later. But the important thing to understand is that how you show a work breakdown structure is very much up to yourself, whether there are any standards in the organization that you're working in. You have a degree of flexibility and choice to use your work breakdown structure. The difficult thing in creating a work breakdown structure is to know that you have all the tasks. And so one of the techniques we would recommend is that you start at the highest level, you find all the major tasks, and then you decompose those major tasks into smaller and smaller tasks until you find that that process is not leading to any further detail or information or useful outcome for you, because you can break these tasks down almost infinitely. But when you start getting down to tasks that are only going to take a few days or hours, there really isn't any point going beyond that level of detail, unless the timing of those tasks is absolutely critical. If something has to be done at midnight on the 31st of December, then you have to plan to the minute to make sure that that task does happen when you need it to. Okay. So, okay. Can I just ask, are there any questions on that idea of decomposing the major tasks of a project into smaller tasks? Because the assignment that we have later is going to ask you to do exactly that. It's going to ask you to imagine a project and then identify the major tasks of the project and then break those major tasks down into smaller tasks. So can I just ask, are there any questions about decomposition as an idea?
My question is, different organizations, they have different ways of decomposing their tasks, isn't it? Or is there?
Yeah, so many organizations will tend to have certain ways of decomposing certain tasks, but often the tasks that are run in business, or the projects run in business, are quite different to other projects. So the tasks that are needed are often quite different. There are some tasks that are similar. So for example, if we need to design a new system, or if we need to design a new process, or if we need to test a system, those sorts of major tasks often are broken down into fairly standard ways as to how you might test a system or how you might design and build a system. So sometimes there will be standard ways, sometimes there won't be, but there is this idea that if you don't know how to break down the task yourself, you may need to engage a subject matter expert to help you understand the best way to break down that particular task. Yeah, is that okay?
Sure.
Yeah. So certainly some tasks do have a standard breakdown in some organizations, but it's also quite rare that that's the case, because every project has to be a bit different to other projects that have been run. So sometimes the major tasks are quite similar, but what actually needs doing at the low level can be very different between projects. Yeah. Okay. So that was the idea of decomposition. It's a very important part of activity-based planning. The next thing we need to think about are the dependencies between tasks, because when a task can start is often determined by the interdependencies. So for example, we can't start to write some software to do a business task until we have at least one business requirement that the software needs to meet. So there's a natural order to things. It's like with the bridge. You can't build the bridge structure until you've built the bridge foundations. And the way that we often record these interdependencies between tasks is to assign each task a unique number. So task 1, task 2, task 3. That would be the task ID. And then once we've assigned a task ID, we can then say, for example, that dependent on task 1 being finished. So we're saying that we can't start task 3 until task 1 is finished. So we can't build the bridge structure until the bridge foundations are built and the concrete is set. So there are dependencies that occur between tasks, and we need to find an efficient way to represent those interdependencies. And the standard way of doing this in the project world is to assign a task ID to each task, a number, and then to refer to the dependencies based on those task IDs. So you might say task 3 is dependent on task 1 being complete. Are there any questions on dependencies? Because again, that's an important concept in activity-based planning.
No.
No, it's fine. Okay. All right, so we'll move on to mention milestones. So a milestone is a point on a plan where a significant delivery has happened. Now that delivery could be the end of a stage. It could be the completion of an important internal deliverable for the project, like a set of business requirements being approved, or like the design for the bridge being finished. Or it could be something that's been delivered that would be of major use to the business, like a new system going live or the bridge being finished. All of those things could be milestones. The important thing is that the milestone is shown on a plan as being the point where a significant delivery has happened. So you might have all the tasks on your plan, but you might also have a milestone that shows when some of those tasks have resulted in a significant delivery. So where some piece of useful work has been completed because we finished all the tasks that were necessary to deliver that useful thing. And when we're using project management software, milestones are often treated as tasks. They look like a task, but they're often set to have a 0 duration, which means that the task takes no time to complete. So a task, for example, like building a bridge, the duration of that is going to be a year. The task of designing the bridge might be 3 months. But the milestone has a 0 duration because it happens instantly. All the tasks that are necessary to complete the delivery have been done. So it takes no time at all to go through the milestone. What it does allow us to do is hang that milestone on the project plan as a task, is it allows us to create dependencies between the milestone and all the tasks that have to be complete for that milestone to be reached. So we would set dependencies from the milestone to all the tasks that need to be done for that milestone to be reached in terms of dependencies. So we create dependencies so that the milestone is completed when all of the tasks that feed into it have been completed. So any question on milestones before we move on?
You're talking about milestones now, yeah? So does it have to be, because I'm a bit confused.
Sure.
Like for example, now let's use the example you gave about building a bridge, right?
Yes.
So if you've actually completed the design, can we refer that as a milestone as well?
Yes, that could be a milestone, and it could be a milestone because it's the end of a stage. So, for example, you might talk about there being a design stage and a build stage. Now, those aren't official stages in terms of project methodology, as we were discussing when we discussed the project life cycle. But within your project, it's not unusual to talk about there being a design stage or there being a build stage. So the end of design would be the end of the stage, and that could well be a milestone. Because you know that all of the thinking has been done, you're now ready to move into the doing of actually building the bridge, because you know what you're going to build. So absolutely, the end of the design stage for a bridge could be a milestone. And I think it probably would be. I think whoever is paying for the bridge, assuming that it's a very major bridge, is going to want to know that all the design problems have been worked out. We know that we can build a bridge that is going to be safe, that's going to be affordable, that's going to carry the load we need to carry. So that's quite an achievement. And one of the reasons that we often set milestones is to prompt us to communicate with stakeholders, to say the project has achieved something, we've got to a certain stage. So you can be clear that we are making progress. You can be reassured that we're making progress here, because we don't communicate with stakeholders every day. There may not be any great success to report every day, but when there has been a significant delivery, like the completion of the design of a bridge or actually finishing building the bridge and being ready for the opening ceremony, that's a milestone, and we want to report that to the stakeholders so they can see that we've made progress. And we can reassure them that progress is being made. So this is why we tend to have milestones, is it prompts us to communicate, it prompts us to celebrate as well when things have gone well and when we've reached a particular stage in the project.
Okay, so we can safely say that each of the project management life cycle is a milestone, right?
Yes, you can safely say that the completion of each stage in a project, so the end of the initiation stage, the end of the planning stage, the end of the delivery stage, they are milestones, and they would tend to be shown on the project plan as milestones. So there would be a task there that would say end of initiation or end of planning or end of delivery. And that task would have this 0 duration to show that it's a milestone. And in fact, most software packages, when you put a 0 duration in for a task, they show the task slightly differently. And I think we can perhaps see that later, where we can see what a milestone actually looks like in a piece of project management software. So I'll try to remember to show you that. Okay, and perhaps if I don't show you that, you can remind me.
Right. Thanks,
Okay.
Tony.
Yeah, no problems. Are you okay if we move on?
Yes, I'm okay.
Yeah. Okay. Yeah. Okay. So the next thing we need to think about is risks. We've mentioned risk quite a lot, and we've said even the purpose of having projects and having projects is very much to do with managing risk. And so we need to think about how risks are handled when we are using activity-based planning. Because it is possible that some of our tasks that we are doing have risks associated with them. And the project manager will need to consider whether any of those risks need to be mitigated. We've met this word before. So mitigated means to reduce the impact of, to lessen the impact. Now, in order to mitigate a risk, we might need to add a new task to our list of tasks. So in order to make the problem smaller, we might need to do something extra. We might need to add a task. We might need to change some detail about an existing task, and that change could make the task take longer, or it could need more resource to complete the task. So, for example, in building our bridge, in order to avoid risks to workers, we might need to tackle the task slightly differently. And that might need, we either need more people, or that it's going to take longer to build the bridge, or that we need more equipment. So maybe more scaffolding than we anticipated. So we may need to change some detail about an existing task. Or the final option here is that we can ask for the risk to be owned outside of the project. Now, we've not done our module on, there is a module, and we'll talk about the different ways in which risks can be mitigated in more details. But one of the options is to get the risk owned outside of the project. Effectively, this means that the project doesn't have to deal with it. Somebody else in the organization is dealing with that risk. So for example, if we're building a bridge, one of the risks is that with a large workforce, there may be injuries, there may be sicknesses. So we need to have some capacity to deal with those sorts of eventualities with the workforce. What you might be able to do is arrange for the organization's HR department to take on the job of finding additional staff if and when they're needed. And that is an example of where the risk might be said to be owned outside of the project. That risk can still hurt the project if the HR team don't deal with that task properly, because it means we may not have all the staff, all the workers that we need to build the bridge. But it does mean that we don't have to have a task on our project plan that says hire more staff if we need them. So these are our options for managing or mitigating a risk. And when we're using activity-based planning, there are really just these options as to how we handle that. We can either add new tasks to the plan, or we can change existing tasks, or we can manage the risk in some way that means we don't have to change the plan at all. But normally that means that the risk has to be managed outside of the project, because everything that the project is doing should be represented on the plan. There's a, I guess it's a sort of unwritten rule that everything that the project is doing should be shown on the plan. The project shouldn't be doing anything that isn't on the plan. It's sort of obvious, but perhaps not so obvious if you're new to projects. So we'll state that now, that everything that a project is doing should be on the project plan somewhere. Okay, so that's how we manage risk when we're using activity-based planning. Are there any questions about risk management when we're doing activity-based planning?
Not for me.
No? Okay. Yeah. Okay. So, once the project manager is confident that the list of tasks is complete, we can move on to identifying the resources that are necessary to complete the task. We can estimate how long the task will take, and we can then schedule that task, because we need to decide when that task is going to start. Based on our estimate as to how long it is going to take, we can see when that task will be due to end. And if there are tasks that are dependent on that task, then we know when those other tasks can start, because we know when our first task will be finished. But one of the things we need to consider is that resources are finite. If we had an infinite number of workers, then it might actually be possible to start and finish every task on the first day of the project. But we don't have that luxury. We don't have an infinite number of resources. So we have to schedule the project tasks, taking into account the resource that's actually available to the project to do the work. And it can be the case that a task may be ready to start because all of the predecessor tasks, all of the dependent tasks have been completed, but there may be no resource available to start the task. And so it has to wait for resource to become available. So in a large organization, there might be a particular expert, and that expert might be working on 3 projects, may finish all the tasks and be ready for that expert to start. But if they're still tied up with an earlier project, then you won't be able to start the task that you want that expert for until the expert becomes available. So once we're happy that we've got our list of tasks, we can move on to estimating the resource that's needed and the duration of the task, and we can then look to schedule the tasks. And this is where it starts to become very useful, particularly as projects get bigger, to have a software tool to help us, because it can help enormously with the scheduling of tasks. And we'll go on to see about how that works in just a little while. So we're going to talk briefly about a concept called Gantt charts. And there's an image of a Gantt chart on the screen. They were invented in around 1910 by a chap called Henry Gantt. And his charts are basically a bar graph that shows the tasks that are to be performed on the vertical axis. So tasks, and it shows time intervals on the horizontal axis. And the width of the horizontal bars on the graph show the duration of each activity. And modern Gantt charts also show the dependencies between activities. And Gantt charts are very useful in scheduling and also for visualizing the dependencies. And we will see this later. We'll be able to look at this in more detail. But the little diagram we've got there, that is a Gantt chart. And you can see that we've got tasks that go down the page, and we've got time that goes across. And in fact, on this particular tool, this is probably showing as days, because you can see we've got 5 time periods followed by 2 that are grayed out, followed by another 5 and another 2. So that's almost certainly days, followed by 2 weekend days, and so on. And you can see that this is also showing us that the work occurs within a phase or within a stage. So there is a dark line at the top that shows us all the tasks that are within that one phase. And this is a common technique within a Gantt chart to show phases or stages, collections of tasks that might be taken together. So, any questions about Gantt charts?
No.
No, okay. Okay. So, if the list of tasks is long and there are complicated dependencies between the tasks and the resources are finite and shared, it can be very difficult to see how long the project will actually take to deliver, even if you know the duration of each individual task quite well. And so during the middle of the 20th century, a number of organizations started to take project management and study it, treat it as a science. And they started to look at the tools that they had, such as the Gantt chart, and started to think about how these tools could be improved. And in 1956, DuPont and a company called Remington Rand Univac, that's now called Unisys, developed something called the critical path method. And this was a method to determine how long any given set of interdependent tasks would take. And most project management software tools implement the critical path method automatically so that you don't learn how to apply the method yourself. They do it automatically for you, and they show you how long the project is going to take. And they do it by calculating the duration using the critical path method. The method itself it's not that complicated, but it is a bit complicated. You can study it. There will be videos on YouTube about the critical path method, where if you want to, you can delve into more detail and understand how that method actually works. But a lot of the time you don't need to understand it, because the software tools that we have available to us now will show you the answer according to the critical path method automatically, without you needing to understand particularly how it works. So there's also around the same time that the critical path method was developed, the US Navy was also doing studies into project management, and they came up with a technique that they called PERT, Project Evaluation and Review Technique. Now, PERT differs from the critical path method in that it actually uses statistical techniques to try to predict the range of durations for a project. So the critical path method gives you one answer as to how long the project will take. It will tell you the project is going to take 15 days or 19 months or 72 weeks. The PERT technique tells you a range of durations. So it will say something like the likely duration for this project is between 4 and 6 weeks, or the likely duration of this project is between 24 and 27 days. So PERT differs slightly in that it's using statistical techniques to try to tell you the likely range of durations for the project. So it uses a similar approach to analysing the tasks, but in order to apply the statistical methods, it needs to have some data about how long similar projects have taken in the past. And although the technique works and it's a good technique, actually in business, trying to find similar projects and finding useful data about how long the project has taken and how long the tasks have taken can be very difficult. And so the method is rarely used. But one of the parts of PERT that is used a lot is the diagrams. So the diagram method or style that was part of the PERT technique. And those diagrams now are often used to show the dependencies between tasks when we're performing the analysis using the critical path method. So if you're performing the critical path method manually, you can use the PERT diagram style. It's a very useful style for showing the dependencies between tasks. We will see this later in the software tool that we look at. But the general PERT technique, because it uses statistical techniques and needs data about previous projects to work, we tend not to use those statistical techniques. But actually, the methodology is sound. And the one thing you can almost certainly say with certainty about a project duration is if your software tells you it's going to take 4 weeks, that's more or less exactly not the time that the project will take. It will take a little bit less than 4 weeks, or it'll take a lot more than 4 weeks. The thing it won't do is take exactly 4 weeks. I think in my career, I've had one project that actually finished when the software tool said it would finish. And that's over hundreds of projects. So the PERT technique is better because it tries to give you a range of durations for the project and tries to encourage people to think about a range, which is actually a more useful thing than thinking about one particular date when the project can be finished by. So that's PERT. Are there any questions on PERT before we move on?
No.
Okay. We will see the PERT diagram. Okay, right. So we also need to think about where and when activity-based planning takes place. So we talked 2 weeks ago about the life cycle of a project, and we discussed the 4 stages that typically occur: initiation, planning, delivery, and close down. And we learned what the deliverables of those stages were. Now, what we can say with activity-based planning is that it takes place any time that a plan needs to be created. And typically we create plans in the first 2 stages of the project. Although I want to mention implementation plans shortly. So we typically create a plan during initiation. That is the plan for the overall project. And in that plan, we might identify the major tasks that we need to achieve. And that might be the end of the plan for the entire project that we create during initiation. But we'll also create a more detailed plan for the planning stage. And we do that during initiation so that we can see what resources we need for the planning stage. We can see what money we need, so we can see how long the planning stage is going to take. So we create a detailed plan for the planning stage during initiation. And then during the planning stage, we follow that plan. Now, you might imagine that in the planning stage, we also create another plan. And the plan we're creating during the planning stage is a plan for the delivery stage. That's going to have lots and lots of detail on it about all the tasks that are needed to build all of the deliverables that are needed by the business to achieve the outcome and the vision that was set for the project. I mentioned implementation. If we need to have an implementation plan will often be an activity-based plan. It's usually created during the delivery stage, and it tells us what we need to do to deliver our deliverables into service, to have them used by the business. So the implementation plan is mainly about going live with what we're delivering, making sure the business can use the system or the processes that we've developed during delivery. So really, any time that we're going to create a plan, we can use activity-based planning. So we start it early in initiation. There'll be a lot of activity-based planning during the planning stage, and we should have a delivery plan then that's fully resourced. And during delivery and close down, we will use the plan to track the progress of the project. And really the only updates that we should make to the plan during delivery and close down is to record progress and completing of tasks. We shouldn't be adding new tasks into the plan during delivery because our planning should have discovered all of what we need. So that's when activity-based planning happens. Are there any questions on when we would use activity-based planning?
No.
Okay, good. Okay, so I'm going to come on to the assignment first, and we'll just set the assignment, and then we'll move on to looking at the software tool and how we use that. So this assignment follows on from assignment number 1, which was to identify a common project that you might complete at home, or some sort of activity that you might do at home that would meet the criteria to be a project. And one common thing that is often identified as such a project is a special birthday party. So it might be a child's first birthday party, it might be an 80th birthday party for a relative. So the assignment here is to start planning a special birthday party for someone by identifying the main tasks that need to be completed to prepare for the party. So thinking here about preparing for the party, what are the main tasks that need to be created, that need to be done? And what I'd like you to do is to identify those main tasks in the form of a list, and then to break down those main tasks into smaller and smaller tasks until you have tasks at 3 levels. So you have a major task, a middle level task, and a very low level task. Yeah. So have 3 levels of tasks, and you can stop when you've got to sort of 16 tasks, because that will give you enough to get the idea of what's involved in decoding a task. What I'd also like you to do is to estimate the time that each of the lowest level tasks will take to complete. So each low level task will have an estimate to how long it will take. So let's say that one of the major tasks is to bake a cake. You might decompose baking a cake into finding a recipe, buying the ingredients, baking the cake, or mixing the ingredients and baking the cake in the oven. So you have another level. And then for the task that is making the cake or baking the cake, you might break that down into mixing the ingredients, pouring it into the cake tin, putting the cake tin in the oven. So you've got 3 tasks there that you could have at the lowest level of detail. So I'd like you to estimate the time that each of those low level tasks will take to complete. And then I'd like you to identify the dependencies between those low level tasks. And on the next slide, I'll show you how I'd like you to present the information. And so that you don't have to refer back to this video recording that will be on YouTube later in the week, I will send you a copy of this table via Telegram so that you have this. So I'd like you to create the table either in a document or in a spreadsheet on Google Drive. And I'd like you to share your answer, your assignment with us by 7 o'clock on Sunday, if that's okay. And if I just show you this table, things might become a little clearer. So this is the sort of table that I'd like you to produce. You'll see that it's got 6 columns. The L1 task, they're the major tasks. So I've used our design a bridge example. So you would start with your major tasks, and you would break your major tasks down into level 2 tasks, L2 tasks, such as surveying the bridge site and designing the bridge to suit the site conditions. And then you would break level 2 tasks down into level 3 tasks. Now, you'll see from this example that there are certain tasks, like surveying the bridge site, that don't actually break down. You don't need to break that down any further because you can estimate how long that will take reasonably accurately. So I've put an estimate there for the level 2 task of 2 weeks to survey the bridge site. When you're doing the assignment, try to think about whether you can break the task down and try to find tasks that you can break down. So for example, if you want to imagine that this birthday party is being held outdoors, you might need to do some tasks around getting enough chairs or something like a tent or a gazebo or whatever have you to put up in the garden. So try to find some tasks that allow you to break them down into 3 levels like this and estimate for the lowest level task you have how long each of those tasks will take, and then try to identify the predecessor task. Now, when we're thinking about the predecessor task, we're talking about the dependencies between tasks. And in order to record a dependency, we need to assign a task ID. So over on the far left-hand side, we have a task ID task. So task 1 is designing the bridge. Task 2 is surveying the bridge site. In the predecessor column, which is the last column, if we want to show that task 4 needs task 2 to be finished before task 4 can be started, we put the number 2 into the predecessor column. And what that means is we're waiting for task 2 to finish before we can start task 4. If we look at task 5, which is the bridge structure, task 5, we're saying here, task 5 can't start until task 4 is completed. And that's shown by the number 4 in the predecessor column. And similarly, we can't start task 6 until task 5 is complete. So is that okay? Does that explain the assignment enough? Do you need to ask any questions about the assignment?
Yeah, Tony.
Yeah.
Yeah. Can you please probably talk more about the tasks, the
Sure.
3 tasks? Yeah. So that I can,
sure. Yes, I can do that. Yes. Yeah. So I'm asking you to think about planning a special birthday party for someone. And I'd like you to identify the major tasks that are involved in that planning of a birthday party. So you need to think about what are the major tasks of planning a birthday party. And one of the tasks that you might want to identify is making a guest list. So you need a guest list. You need to know who you're going to invite to the birthday party. And as part of that, you might break that down into making the list. You might also break it down into sending out the invites. And you might also break it down into recording the replies that you get to that invite, because you might want to keep a record of who is coming and who said they can't come in order to plan the food better. Yeah. Yeah. So you're making the invitation list breaks down into those sort of 3 tasks potentially.
Okay.
Now, can you break down those tasks any further? Do you need to break them down? And I think with those 3, you perhaps don't need to. So let's move on and let's think about something else, some other major task that might be important as part of planning that birthday party. So if we think about making the food for it, the food might break down into food, drink, and birthday cake. Yeah. So
Yeah.
you would take your major task of planning the food and break that down into planning the food that you want to serve, planning the drinks you want to serve, and planning the birthday cake that you want to also serve. So we sort of separate out the birthday cake as being something special. And the reason we've done that is that the approach to the task is slightly different. With the food, we're probably going to buy most of the food. We might make some of it, but we're going to mainly buy the food. What you might do is you might break down the task of making the food into making a list of the things that you are going to buy as food and making a list of ingredients. Exactly.
Okay.
Yeah. So making the ingredient, making a list of ingredients so that you can do a shop and you can buy everything you need. And then another task at that very low level would be to actually make the things that you're going to make with ingredients. Right. And another task that you might add would be to put out the food that you've bought that doesn't need to be prepared. So for example, you perhaps bought some large bags of crisps and all you need to do is tip those bags of crisps into a bowl. So you could break the tasks down into making the food that you bought ingredients for, but then serving all the other food in a way that you want to present them at the birthday party. And then of course making the cake, we've already talked about how you might break that down into perhaps buying the ingredients, finding a recipe, mixing the batter, baking the cake in the oven, maybe icing the cake. So there could be as many as 5 or 6 steps or tasks that you want to list for making the cake. Yeah. So to complete the assignment, you need to create a table like we have on the screen at the moment with 6 columns. Yeah. You need to put your major tasks into column 2, your middle level tasks into column 3, and your most detailed, smallest tasks into level 3. You need to give task numbers to them all, and we've said you can stop when you get to 16 tasks, because by the time you get to 16 tasks, you'll start to get the idea as to how this works. So just 16 tasks. I'd like you to estimate how long each task will take. So think about how long it's going to take you to write a list of who you're going to invite, how long it's going to take to send the invitations out, how long you might need to wait for replies to come back. That might be a step. So that sort of waiting for replies might be a task, although it doesn't need you to actually do anything other than wait. But try to estimate how long those activities will take. And then finally, try to identify what tasks are dependent on what other tasks. So for example, in order to send out invitations, you have to know who you're going to invite. So you have to have written your list of who you're going to invite. In order for people to reply, they have to have received the invitations. They can't reply before they've received an invitation. Yeah. So in the predecessors column, put the task ID of the task that the task is dependent upon. So for example, if task 4 needs task 2 to be completed, put the number 2 in the predecessor column, because the predecessor column is talking about the task ID. And perhaps if you had more space on the assignment, you might call column 6 predecessor task ID. Okay. Just to make it clear that what is in that column is a task ID. You'll notice in our example on the screen that task 2 doesn't have any predecessor. One of the things that means is that you can start that task immediately. If it's not waiting for anything, then you can do that task immediately. You can start surveying the bridge site the moment the project starts. Yeah. And that's what we'll see is when you have no predecessors, it means that you can start the tasks immediately. And I mentioned earlier that if you have an infinite amount of resource, then potentially even with dependencies, you can finish your project in one day. If you have an infinite amount of resource, but no project ever has that. So that's the assignment. Is that clearer?
Yeah.
Yeah.
Just
okay. As I say, I'll send you. Yeah, sure.
Yeah, the numbers, task ID 7, build
yes.
page, right? So that one, so you will see have to break it down into smaller tasks as well. Really.
Yes. Okay. So in this example, because this is a relatively small slide, I stopped at 7 tasks because I couldn't get 16 on the slide and let you see it all. So I've stopped at 7. But yes, you would, if this was your assignment, you would carry on until you had 16 tasks. Yeah. Yeah. All right. So your highest task number should be 16.
16. Okay. All right then.
Okay.
Yeah.
Okay. So that's the assignment. As I say, the recording is available on YouTube. I'll try and get it up tomorrow so that you can have the maximum time to review it if you need to. But that's the assignment. Create a document. It can either be a document or a spreadsheet type of document, whichever works for creating a table, whichever you find easiest to create that table with 6 columns and 16 tasks. So you can present it any way you like, as long as it's got your 16 tasks and your 6 columns, that'll be fine. Okay.
Okay.
Okay. So we're going to do an exercise now. We're going to use the a piece of software to actually look at this example. I'm just going to talk through the example just to start with. So this is an exercise in activity-based planning, and it's a scenario. So your boss is thirsty. They want a cup of tea, and they've asked for a cup of tea with milk and sugar. So we're going to treat this as a project, and we're going to plan delivering a cup of tea to your boss using activity-based planning. And there are some more details about the scenario. So you work in a town centre, and there are various shops and cafes nearby. Your workplace also has a kitchen. It has a kettle and a fridge. And also everybody contributes to what you might call a tea club that makes sure there is tea bags, sugar and milk available in the kitchen at all times. But there are no drinks vending machines on site. So that's our scenario. And we plan this using the techniques that we've learned about today of identifying the major tasks and breaking those tasks down and assigning estimates to them, identifying the interdependencies between the tasks. So the first thing we need to do, and we mentioned this when we were talking about the project life cycle and also when we looked at project initiation in detail, is we decide on how the project is going to approach the task. Because the list of tasks that you will need will be very different depending on your approach. So if we decide to make a cup of tea in the kitchen using the kettle and the tea bags and everything else that's available, the tasks that we need to do will be very different than if we decide to go out to a cafe nearby and buy a cup of tea with milk and sugar. So both options are open to us, assuming we have some money. We could go out to a cafe, we could buy a cup of tea with milk and sugar, or we could go to the kitchen and we could make a cup of tea with milk and sugar. The boss wants a cup of tea with milk and sugar. He doesn't really care how that is delivered to him. He just wants his cup of tea. So we have to choose our approach. And so for the purpose of this exercise, we're going to choose the approach whereby we do make the cup of tea in the kitchen using the kettle and the materials that are there. And the reason that we're doing this is that if we were to go out to buy a cup of tea from the cafe, the task list would be so short as to be trivial. So we need to find an example that's a little more useful to you to understand the process. So we're going to take the approach of making the cup of tea in the kitchen. And what I've done is I have, within our software tool, I'm just going to switch to, I have listed all the tasks that we identified. Okay, so can I just check, are you seeing that on the screen? Are you seeing a list of tasks to make a cup of tea?
Yeah.
Yeah, okay. So the way that I arrived at this list of tasks was exactly this process of decomposition, which is the major tasks are to get some hot water by boiling the kettle, to brew the tea in the cup, to add the milk and sugar, give it a stir, give it to the boss. So what I've done is I've taken the higher level tasks and I've decomposed those into all the low level tasks that we need. And just to make this exercise a little simpler, I've omitted some of those higher level tasks, but in order to discover these low level tasks, I did go through that process of decomposing, but we've already discussed that and you have an assignment on that. So we're going to start this review of the software with these detailed tasks. And you can see there, to fill the kettle, boil the kettle, get a cup, get a tea bag, put the tea bag in the cup, add the boiling water to the cup, wait for the tea to brew, remove the tea bag, add the milk, add the sugar, stir the tea, deliver the tea. So these are our tasks that we need to plan. Okay. And activity-based planning is quite easy if you understand the task. If you know how to make a cup of tea, you can very quickly get to this detailed list of tasks that you need to do. But with a business project, it's much harder to see all tasks that you need. So you will need to engage with subject matter experts, and you will need to start with the major tasks and then decompose them into the lower level tasks. So we could have used Microsoft Project, which is a very good software tool for doing this sort of planning, but I'm using a tool that's called Gantt Project because it's free and also because it's simple. It does everything that Microsoft Project does at the level we need to discuss activity-based planning. But I can show you things on this tool a little more easily than I could with Microsoft Project. But the end result is going to be identical to what Project would do. Okay. Now, one of the things you'll notice with these tasks is that each task begins with a verb. Fill kettle, get cup, wait, remove, stir. These are all verbs. And this is one of the ways that you really know that you're dealing with activity-based planning and not any other sort of planning, because you're looking at tasks and the tasks start with a verb that tells you what you're doing. So you're adding milk or you're putting a tea bag in a cup. So look for the verb when you are looking to describe your tasks. So, make a list of who to invite to the birthday party, bake a cake. Look for the verb and have the verb at the start so that it's clear that you are doing activity-based planning and that you're referring to a task that needs doing. Okay, so you'll see that the software tool actually allocates an ID number to each task automatically. I've not had to type those ID numbers in. You'll have to take my word on that, but I didn't have to type those in. The software did that for me. And you'll notice how they actually all start all the tasks, they all appear to start on the same day. And if we look over to the right-hand side, you can see we have a Gantt chart where we have Mr. Gantt's chart with the tasks arranged vertically and time arranged on the horizontal axis. So we're currently looking at a situation where at the moment, every task is going to start on the 1st of April, 2020. And each task is the same day. That's what the length of these bars is showing. So it starts on the 1st of April and it's finished by the 2nd of April. So at the moment, every task is just going to take one day. Now, tasks taking a day is realistic in the project world. Some tasks do take a day, but in our simple example, it doesn't take a day to fill a kettle or a day to boil a kettle. So what we're going to do is we're going to work around a limitation of this particular tool. And the limitation of this tool is that it doesn't allow us to plan minute by minute. So we're going to work around that by treating the days on the horizontal scale as being minutes. So effectively what we're looking at now, if we make that assumption that the days are minutes, is we're looking at filling the kettle taking 1 minute, boiling the kettle taking 1 minute, getting the cup taking 1 minute, getting the tea bag taking 1 minute. And we're just using the scale and just adjusting our view of the scale so that instead of thinking about days, we're thinking about minutes. Okay. Oops. Okay. So one of the things that I'm going to change here is I'm going to say that boiling the kettle is going to take 3 minutes because I want the tasks to be a little more interesting. I want them to be more realistic as well. So we're going to say that boiling the kettle is going to take 3 minutes. So in this particular tool, I click on the task, I select it, and I click on this information button here, which takes me to the task properties. And you can see that in the middle of the page here, I've got a duration, and that's currently set to 1, which we're imagining is going to be 1 minute. But we need to change that because we're saying that the kettle is going to take 3 minutes to boil. So I change that to 3 and I click OK. And you'll see, as per Mr. Gantt's chart, we've now got a task that takes 3 units. So by the start of minute 4, boiled our kettle. The other thing I'm going to change about the duration is how long it will take for the tea to brew. So when we're waiting for the tea to brew, I'm going to change the duration of that to 2 minutes. So again, I go to task properties, I change the duration to 2, meaning 2 minutes, and I click OK. And you can see that that task has now got longer on the Gantt chart. Okay. So we've now got reasonable estimates for how long each task is going to take. Filling the kettle probably will take a minute. Getting the tea bag might take a little bit less than a minute, but let's say it is going to take a minute to do that. So we've got reasonable estimates. Next thing we need to think about is dependencies. And you'll see that we have a column called predecessors, but currently there are no task IDs in that predecessor column. So at the moment, nothing is dependent on anything else. And in project terms, that means we could, in theory, start every task on the first day of the project or in the first minute of the project. But of course, in real life, that isn't the case. We have to wait for the kettle to boil before we can add hot water to the cup. So we need to think about when we can start task 1. Now, task 1 can start immediately. We need to think about when we can start task 2. Now, task 2 has to wait until the kettle has been filled. We can't start boiling the kettle with no water in it. And in this particular tool, we have 2 ways of setting the dependencies. One way is to go into Boil the Kettle, click on the task properties, and you'll see we have a predecessors tab where I can add something that the task is dependent on. And we can select what task we want this task to be dependent upon. And because fill kettle was the first task, it's sort of defaulted to that, and that's fine. So we can click OK, and you'll see now that on the task called boil kettle, we now have number 1 in the predecessors column. And that tells us that we have to wait for task 1 to be finished, the kettle to be filled, before we can boil the kettle. And you can see on the Gantt chart that the software has shown us that we have this interdependency between the tasks by drawing a little arrow on the Gantt chart at the end of task 1 that links to task 2. And you can also see that that arrow has effectively pushed out the point at which that task can start, so that it's moved from being able to start in the first minute to having to start at the beginning of the second minute, because it's had to wait for the kettle to be filled. Okay, so this is how this particular tool shows these predecessor tasks. So what I'm going to do now is I'm going to more quickly add the predecessor tasks for things. And I think if I'm right in remembering, yes. So one of the ways that we can add these dependencies is we can drag them from the bars. So for example, let me just find this. So right, the task 5, putting the tea bag in the cup. In order to put a tea bag in a cup, I need a cup and a tea bag. So what I'm going to do is I'm going to drag the dependency like that. And that's quicker than going into the task properties box. So I could go into the task properties box and I could add the dependencies that way, but I can also do it by dragging the dependencies on the Gantt chart. And you can see that what that's done is it's done 2 things. It's put the numbers 3 and 4 into the predecessors column. So I can now see that task 5 is dependent on task 3 being finished and task 4 being finished. And you can see that on the Gantt chart, that's actually pushed out the time at which task 5 can start. If we can get the cup and the tea bag in the first minute, we have to wait for those 2 things to have happened before we can put the tea bag in the cup, because we need both things at once to be able to do that. So we have to wait until the second minute to actually be able to drop the tea bag into the cup. So that's pushed out the time at which that task can start. So that was task 5. So what I need to do now is, having got the tea bag in the cup, I need to add hot water to the cup. And for that, I need the hot water that's in the kettle. So I need this. And I also need the cup with the tea bag in it. So I need both of those things in order to be able to add the hot water to the cup. And you'll see that what that's done is, in the predecessors column for 6, it's put number 2, boiling the kettle, and number 5, putting the tea bag in the cup, as being the predecessor tasks. And because we're waiting for task 2 to finish and task 5, that's actually pushed out the time that we can actually add the hot water to the cup to the start of minute 5. So you can see how, because task 2 is longer than task 5, it's pushed out the point at which we can start task 6 to minute 5. See that?
Yep.
Yeah. Okay. So once we've got the hot water in the cup, we can now wait for the tea to brew. So task 7 is just waiting on task 6 to be done. And once we've done task 7, we can then remove the tea bag from the cup. So we can create that dependency there so that task 8 is dependent on task 6. So we've taken the tea bag out of the cup. We've got some brewed tea in the cup. We now need to add the milk and sugar. And it doesn't actually matter in which order we do that. So I can show that our dependency is like this. So we need to add the sugar, we need to add the milk, and we need to do both of those things before we can stir the tea. If we try to stir the tea before we've got both of those things added, then we won't necessarily get the best result. So I will create a dependency from adding sugar to stirring the tea and a dependency from adding the milk to stirring the tea, so that both of those tasks need to be done in order to stir the tea. And you'll see in the predecessors column, task 11, stirring the tea, is waiting for tasks 9 to be done and task 10. And then finally, once we've stirred the tea, we can create the final dependency we need in order to give the tea to the boss. Okay. So we've added the dependencies there, and that's good. That's a necessary step in activity-based planning. But we now need to consider what resource is available to do the work. Because according to this, we can fill the kettle, get the tea bag, get the cup, all within the first minute. Now that may be possible if you're superhuman and the kitchen's small and you race around like a mad thing. But in practice, when resources are limited, say for example, if there is just one person that's going to make this cup of tea, it's probably not possible for somebody to do all of these tasks at once. And so we say that these tasks are constrained by the resource. And if we can add a resource to our project, we can add a person to the project plan, and we can assign them to the project, and we can assign them to the tasks, we can see what the effect is of having just one person that can do all of these tasks. If these tasks were bigger, so say for example, filling the kettle wasn't filling the kettle, but designing a new system, and getting the cup wasn't getting a cup, but was buying a new building to put a whole load of people in, you can see that one person isn't going to be able to do those in 1 day or 1 minute. So we need to think about the resources that we have available. And in order to add resources that we need to do these tasks, I'm actually going to load a copy of a file that I've saved previously. So because this is a software tool, it works just like many software tools where you can go to the top left and you can do a save, and you can save a copy of your project plan. What I'm going to do is I'm going to open this. I'm not going to save this because I already have a copy of this. And I'm going to load this file here, cup of tea 3. Okay. And so what we have is exactly the same project plan, but we have a resource column now. And I've called this resource U. Just going to spread these columns out a bit so you can see that. So we now have a resource. And if we click on the resource chart, which is one of the tabs up the top, we can see the effect of that. And what this is showing us is you'll notice already that there is some red on the chart and there are some numbers. The numbers are probably too small for you to see on the screen, and this tool doesn't allow me to make these very much bigger. So I'll just tell you that in the first minute, the number there says 300%. In the second minute, it says 200%, and in the 9th minute, it says 200%. And what that basically means is that we are asking you to do 3 times as much work as you can possibly do in the first minute. So you are overcommitted. We're asking you to do too much. In the second minute, it gets a little easier because we're only asking you to do twice as much work as you can do in a minute. In the 9th minute, the pressure doesn't let off because we're asking you to do twice as much work as you can actually do. But at least by minute 3, you're starting to only be asked to do the amount of work that you can do. And if we click on this plus sign here, you can actually see the tasks, and you can see why we have this overcommitment, because we're asking you to do 3 things at once: fill the kettle, get the cup, get the bag. And we want you to do those 3 things all at once. In the second minute, we're asking you to boil the kettle and put the tea bag in the cup. Now, actually, when you understand the task, that is actually quite feasible. It doesn't actually take any time at all for you. You can go off and do other things while you're waiting for the kettle to boil, assuming it's an automatic kettle. So we can solve that problem by taking the resource off the kettle task. So if I go to the Gantt chart, go to boil the kettle, and I go to the information tab, and I go to resources. The resource here is you, but I can delete that. I can delete you from that, and I can click OK. Let's just check that it does delete. It hasn't deleted yet. Has it actually deleted? Let's try it again. So it hasn't deleted it. There we go. All right. Now you'll see that there's no you in the resources. So there's now no, you're not assigned to that. And if we go to the resources chart, you'll see the effect that that's had on the project plan. We now haven't got the red 200% in minute 2, and you've actually got some free time in minutes 3 and 4 because there apparently are no tasks for you to undertake in that time. But we still have these red tasks where we have the 300% here. Now, this seems sort of fairly obvious now in that what you might do to solve that, because filling the kettle is the first job, but we can move getting the cup to another period. We could move getting the cup to some of this time when we're not doing anything. So let me just check my notes to see where we go. Okay. So if I go to the Gantt chart, we can try moving get cup so that it starts at minute 2. To do that, I go to the task properties and I set the start to be minute 2, which I have to do is say as April the 2nd, that's minute 2 for us on this. And you can see that that jumps get cup out so that it starts at minute 2. And if we look at the resource chart again, we'll see that the 300% that we had in minute 1 has gone down. That now says 200%. So we're starting to solve our resource problem. by moving tasks to time when we're not. But we still have that 200%. So can we move getting the tea bag out? Yeah, go ahead. Yeah. So the problem is if we move getting the tea bag to the same time that we're getting the cup, we're just going to recreate that problem. But let's just prove that. So I'll go to get tea bag and I'll move that to also start on the 2nd of April, which is minute 2. And if we look at the resource chart, you can see we fixed the problem for minute 1, but we've just moved the problem to minute 2. Right. What we have to do is we have to move getting the tea bag out a little further. So say move it to minute 3, and we'll see what that does to the resource chart. Now we've solved the problem. Yeah. You can see we've not got any of the red overcommitment in minutes 1, 2, or 3. So we now know that we're starting to get on track with this. And the only problem that we have now is at minute 9, where we have some overcommitment. So we need to look at minute 9. And if we look at minute 9 on the Gantt chart, we've got 2 tasks, adding the sugar and adding the milk. And we're saying that we can't both do these at once because we've only got one resource. Now, if we could get somebody else to join us on the project for that 1 minute, that might help, but that might be an expensive thing to do just to do that. So the thing we could do is we could change the start time for adding the milk and add a minute to that. So if we change it from minute 9 to minute 10, did that work? Sometimes I don't always. Okay, so what's happening here is that the tool doesn't understand that we want to move the start date, and it's trying to automatically schedule the task to start as soon as it possibly can. And if we look at this task again, and we look at the predecessors here, you'll see that it's got this link hardness column at the far end. It says it's a strong link. The alternative is it's a rubber link. And this is what we need to change in order to allow us to set that start time to be 10. If we set that start time there and click OK, you can see now the task 10 does move out to minute 10, and that pushes the other tasks out further. What I'm just going to do, so you can see that again, and I'm going to just undo that change that we made, and just draw your attention to the fact that at the moment, this project finishes at the end of minute 11. So according to the automatic schedule that this software tool can produce, the project is going to take 11 minutes for you to prepare the cup of tea for your boss. You'll have that cup of tea done by the end of minute 11. But currently, we've got this overcommitment on the resource that we still need to solve. And the way we solve it is by moving the start date out so that we can move this to the 10th. Because of how the dependencies work in this particular tool, we have to change this link hardness from strong to rubber in order that we can actually push it out far enough. And so what that shows us is that now, instead of the project ending at the end of minute 11, it now ends at the end of minute 12.
Oh, yeah.
But if we look at our resource chart, you'll see we have no red here. So this tells us that we have enough resource to deliver the project. If we had red on this, it would be saying you're asking somebody to do the impossible. You're asking them to do 2 or 3 or 4 or 5 times more work than they can actually do. So the project manager has to schedule the tasks to be done in such a way that none of the resources are overcommitted, none of the resources are overstretched. And the way that we do that is by moving the tasks around to find the earliest time that they can start when we have resource available. So it's that idea about when the resource is available. Okay.
Right.
Yeah. Okay. So that's the, we've seen the Gantt chart, we've seen the resource chart, and we've seen the task properties where we can set durations and how the dependencies work. The final thing we need to look at is just the PERT chart. We mentioned the PERT chart, project evaluation and review technique, earlier. And if I just show you this PERT chart, you can see that we have a diagram that shows the relationship between the tasks. So we have to fill the kettle, and that then feeds into boiling the kettle. We have to get a cup, have to get a tea bag, put the tea bag in the cup, add the hot water to the cup. So you can see the arrows are showing us how these tasks are interrelated. But you can also see that we have the durations shown and we have the start dates shown. And I think what you'll realize is that this is showing us no more information we saw on the Gantt chart. It's showing us exactly what was on the Gantt chart, but the format is different. It's showing it as a PERT chart and not as a Gantt chart. So you can see the difference between the two charts there. So that's the PERT chart, that's the Gantt chart. And in project management, the Gantt chart is the most popular, but the PERT chart is also used, particularly if you're trying to apply the critical path method manually, because you need to know, it's actually easier to work if you have the information laid out in this format when you're trying to do the critical path method. So that's the software tool, and that's the basic process of activity-based planning. And just to wrap up, I just sort of mentioned that what you can see from this tool is that the end date for the project probably is better expressed as a range of dates or a range of times, because the estimates that we have for how long things will take are not precise. Getting a cup might take a bit less than a minute. Adding the milk and sugar might take a bit less than a minute. Stirring the tea might take a minute if we're thorough, but might take a little bit less. So depending on exactly what the real timescales are for things, in reality, the likelihood is that this project is going to deliver a little bit ahead of when the tool says it would deliver. But that's probably a good thing, because the boss will be thirsty. He'll be expecting his cup of tea by minute 13. So we need to be sure that we can deliver his cup of tea by minute 13. And this tool has shown us how we can do that. So what I will do as well, when I put the information up on the assignment on Telegram, I'll also give you links where you can go and look at and even download this Gantt project tool, because it's free. it might be useful to you to have a play with and to learn a little bit more about it if you want to. But that's the basic method. So I'm just going to switch back now to our PowerPoint presentation just to wrap up. Okay, right, okay. So can I just ask, are there any questions about anything that we've seen tonight in terms of activity-based planning, how you do it, how a software tool might help you to estimate the duration of your project?
I think probably you've actually said you're going to send us a link.
Okay.
On how to access the Gantt and the PET
yes.
chart. So which means we can go in there and practice on our own, which will make it more easier for us.
Yeah. So there are indeed. So there are a number of different software tools out there that you might use. Microsoft make one. There are many other software packages that will allow you to plan projects using activity-based planning. The process that we've tried to explain tonight is you need to identify the tasks, and the best way to make sure you don't miss any tasks is to identify the high-level tasks, the major tasks, and then break those down into more detailed tasks. You then need to estimate how long those tasks will take for the resources that you have available. Oops. And that could, the amount of time that a task takes will differ depending on the resource you have. If you have an expert available to work on the task, it will take that person less time than if you have a novice working on it. So you need to estimate the duration in the light of the resource that's going to be doing the work. You then need to figure out the interdependencies between tasks, and based on the durations and the interdependencies, with the help of a software tool, you might discover that you need to change some of the start times and dates for tasks because you have resources that are overcommitted. People can't be working on 7 or 8 things at once. So you may need to do some work to separate out the resources. Now, one of the advantages of some of the more advanced tools like Microsoft Project is they will actually do that resource leveling, as it's called, for you automatically. So you can put your tasks in, you can put your resources in, your estimates in, and you can see where you've got that resource overcommitment, where you're asking people to do more work than it's physically possible for them to do. And you can ask the tool to automatically move tasks around to find you the best way of delivering the project in the shortest possible time. And the tools will use the critical path method, and they will figure out what's the shortest time that the project can be delivered in, and they will find the optimal time for each task to start based on your resources, your estimates, and your interdependencies. So these software tools are really useful for project management. And with large projects, they're absolutely vital. You couldn't plan the sorts of large projects that you see being delivered in the world today without having these software tools to help. So if that's okay, I'll wrap up there. I will put some information on the Telegram site tonight about the assignment and the link to the Gantt software. If you want to have a look at that, there is other software out there. The recording will be on YouTube when I can get it to YouTube. And if you're okay, I'll end the session there. Is that okay?
Yeah, thanks, Tony.
Okay.
Okay.
No
Thank
problems.
you.
Have a good evening, everyone.
You too.
Bye.
Okay. Bye, everyone.
Bye.